In this video, we're going to talk about atomic structure and electronic configuration. In a series of investigations conducted in the 19th century by scientists, it was discovered that the atom is made up of three subatomic particles, three basic subatomic particles. So we have the electron, we have the proton, and we have the neutron. These are the three basic subatomic particles that were discovered in the 19th century. Electron was discovered by the scientists J J Thomson, Joseph John Thomson. Proton discovered by Ernest Rutherford, and neutron discovered by James Chadwick. We are not going to be going into the historical details of this discovery in this video, but we'll focus more on the fundamental properties of each of the subatomic particles, and also we'll focus on writing electronic configuration, both shell and orbital electronic configuration. So the electron, let's start with the electron, is a very light subatomic particle and it carries a negative charge. The electron carries a negative charge. It is a negatively charged particle, and one particular thing about the electron is that it revolves around the shells or energy level. Electrons move around the shells or energy levels around the central nucleus in an atom. Alright, so we also have the protons. Protons are positively charged. They are positively charged particles, and they are present inside the nucleus of an atom. And the nucleus of an atom is kind of like the central part of the atom where most of the atomic mass is concentrated. And also we have the neutron. The neutron has no charge. We can say it is neutral. It is neither positively charged nor negatively charged. It is neutral, and it is also present inside the nucleus of an atom. So we can view an atom as an empty space containing a central nucleus. And this central nucleus contains protons. Let's represent protons by positive charges and neutrons by this dot because they are neutral. And then it has electrons moving around shells. Has electrons that are negatively charged moving around shells or energy levels, something like this. Let's say this is another shell, and we have negatively charged electrons moving around the shell, moving around the shell, moving around the shell, moving around the shell. So this is a simplified diagram of an atom, atomic structure, in which we can say that this center is the nucleus of the atom, and this nucleus contains the proton. The nucleus contains the protons that are positively charged and neutrons that are neutral, no charge. These are shells. We can call them shells. We can call them orbits, or energy levels. And on these shells, we have electrons that are negatively charged moving around the shell. Electrons moving around the shell, or orbits, or energy level. This is a very, very basic and simplified diagram of an atom, because at an advanced level, this is really simplified. So let's just keep it that way. At an advanced level, an atom is more complicated than this. But this is a very basic, simplified diagram of the atomic structure according to the discoveries made in the 19th century. So now that we've known that an atom contains protons, neutrons, and electrons, let's talk about atomic number and mass number. What do we mean by atomic number? Atomic number is the number of protons in the nucleus of an atom. So atomic number is simply the number of protons. When you count the number of protons in an atom, you have the atomic number, and it is represented by Z. We generally represent atomic number by letter Z. So for instance, if I say what is the atomic number, what is the atomic number of, let's say, oxygen atom? Now, you have to learn, or you probably have to learn the first 20 elements on the periodic table, and these elements are arranged according to their atomic number. So if we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, that's number 8 in that order. So if we say oxygen, O, is number 8 on the periodic table, this 8 is actually the number of protons present in oxygen atom. So which means that oxygen contains 8 protons, and then if oxygen contains 8 protons, the atomic number is equal to 8, because atomic number is the number of protons. So that is very clear. So in the same way, we can say that what is the atomic number of, let's say, sodium? So on the periodic table, what is the number of sodium? We are if you read it again, from hydrogen, sodium is number 11. So that means it has 11 protons. And then the atomic number Z is equal to 11. Is that clear? All right. So now let's talk about mass number. It is the sum of protons and neutrons in the nucleus of an atom. So when we have protons plus neutrons, that will give you mass number. Protons plus neutrons is equal to mass number. Now, this mass number sometimes is also called nucleon number. Because apparently, because protons and neutrons are both present in the nucleus, both of them together are called nucleon. So sometimes mass number is also called nucleon number, and it is represented by A, capital A. So now I have to say that generally the atom of an element is expressed by the atomic symbol. Let's represent the symbol by X, and then you have the mass number as a subscript at the left, as a superscript at the left, and the atomic number as a subscript at the same left. So if you see an element written in this way, such that you have a number here as a superscript. This number here is the mass number, while the number written as a subscript is the atomic number. For example, if we go back to sodium, if we have sodium written like this, Na2311, that tells you that this 23 is the mass number, which is the total number of proton plus neutron. That means we have 23 total sum of proton and neutron present, while we have 11, the atomic number is 11, which means we have 11 protons. Now, the question is this: if we have 23 mass number and we have atomic number to be 11, can you guess what is the number of neutrons? What is the number of neutrons present? What is the number of neutrons present? It's very simple to know the number of neutrons present. We say that the mass number is the sum of proton and neutron. So if the mass number here is equal to 23, which is the sum of proton and neutron, and the atomic number is equal to 11. Remember that this is protons plus neutrons, while atomic number is just protons. So now, to know the number of neutrons present, we can just substitute 11 here, which is the number of proton, into this equation. So we are going to have 23 is equal to 11 plus neutrons, because we know that the proton number is 11. We have 11 protons. So if we substitute 11 into the equation, we are going to have 23 minus 11 is equal to neutron. So we are going to have neutrons is equal to 12. So which means that sodium atom has 12 neutrons, 11 protons. That is why the mass number is 23 in total. I believe you understand that. So now let's talk about electronic configuration. Electronic configuration is just the arrangement of electrons around the shells of an atom. All right. Now, generally, for an atom in its ground state, which is the most stable state of an atom, the number of protons should be equal to the number of electrons, in the atom. The number of protons should be equal to the number of electrons. And remember that the number of protons is the same thing as the atomic number that we discussed earlier, the atomic number. So in the ground state of an atom, the atomic number is usually equal to the number of electrons, because the number of protons and the number of electrons are equal to each other. Remember that protons are positively charged, while electrons are negatively charged. So we need to have equal number of protons and electrons in an atom in its ground state, so that the two can cancel out each other. Positive cancel out negative. So we have a neutral atom that is not charged. So now let's go back to the previous example, sodium, with mass number 23 and atomic number 11. So now, in this sodium, we can say that this sodium atom contains 11 protons, right? Which is the atomic number, 11 protons. Atomic number is the number of protons. Now, because we say that in an atom in its ground state, the number of protons and electrons must be the same. So 11 protons, we also mean that we must have 11 electrons. Do you get that? 11 protons also means we have 11 electrons. So we can say that this atomic number can also tell us how many electrons are present in the atom. So 11 protons, 11 electrons. And remember that we did the calculation for number of neutrons. We subtracted 11 from 23 and we got 12 neutrons. Because this mass number is the sum of protons and neutrons. The sum of protons and neutrons. So if we add these two together, we are going to return back to 23, which is the mass number. I think this is clear enough. All right. So now, how do we write electronic configuration of an atom? So in chemistry, there are two kinds of electronic configuration that we write. And for beginners, we are going to start with shell electronic configuration. There's another kind of electronic configuration called orbital electronic configuration. So let's start with shell electronic configuration. Shell electronic configuration is very simple to write. It follows the formula given by Nebor that the number of electrons in a shell is restricted to the formula 2n raised power 2. So now, if we have a particular atom, like we said earlier, electrons move around the shell, and we can have different shell depending on the size of the atom. And so if we have this n, 2n squared, this n represents the principal quantum number. You may be wondering, what does principal quantum number mean? Don't worry about that for now. It just tells us the energy level, the number of energy level present, or let's just make it simple, the number of shell present. So if n, the principal quantum number, is equal to 1, how many electrons can be present in that shell? That is shell number 1, principal quantum number 1. If we use 2n raised power 2, that will be 2 multiplied by 1 raised power 2, which will be equal to 2 times 1 raised power 2 is 1, 2 times 1, 2 electrons. Which means that for first shell, the number of electrons that can be present, the maximum number of electrons are 2 electrons in the first shell. And this first shell is usually called the K shell. Alright, so now how many electrons can go into the second shell? N is equal to 2. When n is equal to 2. So when n is equal to 2, we are still going to use the same formula, 2n raised to power 2, which will be 2 brackets 2 raised to power 2, which will be 2 multiplied by 2 raised to power 2 is 4. 2 times 4, that will be 8 electrons. So which means that for the second shell, it can have a maximum number of 8 electrons, and this second shell is known as L shell. So let's also do that for the third shell, where we are going to stop for this particular video, because we won't go beyond the third shell. 2n squared is equal to 2 multiplied by 3 square, which is equal to 2 times 9, 18 electrons. So which means the third shell, which is the M shell, can occupy up to 18 electrons and not more than that. Alright. So now, which means when we are writing electronic configuration, we are going to follow this sequence. We fill the electrons according to the shell, K, L, M, N, O, and so on. And we've seen that the first shell, which is the K shell, can only occupy 2 electrons. The second shell, which is the L shell, can occupy up to 8 electrons. And the third shell, which is the M shell, can occupy up to 18 electrons. Do you get? So now, to write the electronic configuration, let's go back to sodium, which remember is 2311. To write the electronic configuration of sodium, first of all, we have to ask, How many electrons do we have? How many electrons are present? We are accounting for a total of 11 electrons, right? 11 electrons. Remember that this atomic number can also tell us the number of electrons, because the number of protons and electrons are always equal. So we are accounting for a total of 11 electrons. So how do we write the electronic configuration? All right, we are going to have how many electrons out of this 11, how many can go into K shell? Just 2, which is the first shell. So we have 2, comma. So out of 11, we put 2 in the first shell, then we are left with 9. Out of the remaining 9, 8, the next shell, which is L shell, can only occupy 8 electrons. So 8 will go into the L shell, comma. Then we have just 1 electron left, because if we add 2 and 8, 2 plus 8, that is 10. Take it away from 11, we have 1 electron left. So we put the remaining 1 electron in the next shell, which is M shell, that is 2, 8, 1. And this is the shell electronic configuration of sodium. Shell electronic configuration 2, 8, 1, which means 2 electrons in the K shell, 8 in the L shell, 1 in the M shell. All right. Let's try another atom. Let's say we have carbon, 13, 6 carbon. What is going to be the electronic configuration of carbon? Here we have carbon 13, 6. How many electrons are present? We have 6 electrons in total. 6 electrons. Now remember, the first shell is the K shell and it can take just 2 electrons. So we put 2, comma, in the first shell. So out of 6, we put 2 in the first shell, we are left with 4, which means the remaining 4 goes to the L shell. So the electronic configuration for carbon is 2, 4, 2, 4, where 2 electrons are in the K shell, while 4 electrons are in the L shell. Now, for this electronic configuration, we can also represent it with diagrams of the atom. For beginners in chemistry, you may be faced with a question that will tell you to write the electronic configuration of atom and represent it by diagram. So let's do that for sodium and carbon. So we can have the diagrammatic representation for sodium. We remember that the electronic configuration is 2, 8, 1. So what you are going to do is to just represent the nucleus with a dot at the center, because you are not concerned with the nucleus, you are dealing with electronic configuration, so you are focused on the electrons. And then you have the shell around the nucleus. The first shell is the K shell. It has 2 electrons. We usually represent electrons by dots, by a circle or a cross. So but I prefer using cross. So we have 2 electrons in the K shell. You can put 2 electrons, 1, 2, and then make another shell, which is the L shell. You have 8 electrons, so you can put 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And then you still have another shell, which is L shell, containing 1 electron. So make another shell and put the remaining 1 electron, 1. That sounds clear. Yeah. All right. So let's do the one for carbon. Remember, the electronic configuration we got for carbon was 2, 4. So we are accounting for just 2. Shells. Make a dot to represent the nucleus. Then the first shell, contains 2 electrons, 1, 2. Then make another shell containing 4 electrons, 1, 2, 3, 4. So we can say this is the electronic configuration of carbon with diagrammatic representation. All right. So in our next video, we're going to deal with orbital electronic configuration. Orbital electronic configuration. And in that video, we are going to be talking about Aufbau principle, Unschur, and also polar exclusion principle. That is where we are going to be writing electronic configuration using stuffs like 1s, 2s, 2p. You might have come across it. So see you in the next video. Thank you for watching and have a very good day.